Hello everyone, welcome to episode 8 of our Python programming series. In this video, we are going to learn about one of the most powerful libraries for data analysis, that is Pandas. This video is going to be very interesting. Without wasting time, let's get into the video. First things first, let's know what is Pandas. Pandas is a open source Python library widely used for data analysis and data manipulation. Whether you are handling spreadsheets, time series data, or even large data sets, Pandas makes data manipulation and analysis very easy. Pandas provide high performance and tools to clean, analyze, and visualize data with ease. Next, let's learn how to install and import Pandas. To get started with Pandas, you need to install it using the simple command pip install pandas, where this command will download and install the pandas package along with its dependencies it required. Coming to importing pandas, we commonly import pandas in the form of alias as pd. This alias make your code cleaner and saves time. Just imagine writing pandas as 100 times in a code. It will be hard, right? That's why in place of pandas we use alias, that is pd. Moving on, let's learn about data structures in pandas. Pandas basically revolve around two key data structures, series and data frame. Series and data frame are the cornerstone for data manipulation and analysis in Python. With series, you can get a powerful one-dimensional array-like data structure that can hold data of any type like integers, strings, float point numbers, etc. And it is perfect for handling single column of data. It is similar to a column in Excel spreadsheet or a single column in a database table. On the other hand, data frame offer a two-dimensional table allowing you to work with multiple columns similar to a spreadsheet. It is like a table with rows and columns. These structures provide a wide range of functionalities from easy data cleaning and transformation. By mastering these tools, you can handle complex data tasks with simplicity and elegance, making data analysis more efficient and powerful. Next up, creating a data frame. As I have already said, a data frame in Pandas is similar to a table in relational database or Excel. Creating a data frame is very simple. You can create it from various data structures like list, arrays, dictionaries, CSV files, Excel files, or even SQL databases. The first step in creating a data frame is importing pandas by using import pandas as pd. Next, we will create a dictionary. You can also take various data structures as I mentioned like list, arrays, CSV files, Excel files and SQL databases. Coming to this example, we created a dictionary where the key represent column names and the values are lists containing data for these columns. In the next line, we use pd.dataframe function to convert our dictionary into a data frame. In the last line, let's print the data frame to see our data organized in a tabular format. Here is how the output looks like, where the keys, product name and sales are the column names and these values are lists containing data for these columns. That's it, we have successfully created a data frame from a dictionary in just a few simple steps. For a quick revision in creating a data frame, first you need to import pandas, next you need to create a data directory, next create the data frame, lastly display the data frame. Moving on, let's learn how to read data from files. Reading data from files is a fundamental skill for any data scientist or analyst as it allows you to easily import and work from different datasets. As we all know, data often comes in various file formats like CSVs, Excel sheets or JSONs. Pandas can read them all. To read data from files, first make sure you have pandas installed and you need to import using import pandas as pd. Next, you can specify the file you want to read like CSV, Excel and JSON. First, let's read one of the most common formats for storing data, that is CSV. This will load the CSV file into the data frame df This read underscore CSV function helps you to specify the CSV file name and can handle many variations of CSV files. This is how we read CSV files. It is also similar for Excel and JSON files. You need to just replace read CSV into read Excel or JSON with your file names and you will be ready to analyze your data in Excel and JSON. Next, let's learn about basic data frame operations. Let's take a look at most commonly used operations. To perform these operations, first you should have created a data frame. To get a quick look at your data frame, we can use head method to view first 5 rows. By running print df.head method, you can display the first 5 rows of your data frame. Next, to get information about the data frame, you can use the info method to get a summary of your data frame, including the number of entities, column names, and data types. By running this line, you can get information about the data frame. Lastly, for getting statistical summary, you can use this describe method, which will return mean, median, mode, min, max, etc. of that data frame. By running this line, you can display statistical summary. Coming up, let's learn how to handle missing value or missing data. Missing data can be a nightmare for analytics and is a common problem when working with the real world dataset, and it is crucial to know how to handle it effectively. To do that, the first thing is to identify where the missing data is. You can use isNull method to see where the values are missing. This isNull method returns a data frame of the same shape with true indicating missing values. Also, you can use .sum method along with isNull method to get a quick summary of the missing data. This will give you the count of missing values of each column. Next approach for handle missing data is to fill missing data. For that, we use fill_na method. This method will replace the missing values with 0. Lastly, to handle missing data is to drop the rows or columns that contains them using the drop_na method. By mastering these techniques, you can ensure your data is clean and ready for analysis. Moving on, let's learn how to access columns and rows. Accessing rows and columns is fundamental for data manipulation and analysis. To access a single column, you can use the column name as key, which is similar to accessing a value in dictionary. To access multiple columns, you can provide multiple column names. To access rows, Pandas offer two primary methods for selecting data from a data frame. They are ILOC and LOC, where this ILOC is used for integer based indexing, meaning it selects data by the row position. On the other hand, LOC is used for label based indexing, meaning it selects data by row labels. This is the syntax for ILOC, which accesses the first row, and it is used when you need to access data by specific positions like in a list. This is the syntax for LOC. This is used when you need to access data by specific labels like in a dictionary. I hope this gives you the basic difference and when to use them. Next, we will learn about how to modify data in data frames. Modifying data is essential for cleaning, updating, and transferring dataset to meet specific needs. If you want to add a new column profit, you can add it by subtracting the cost column from sales. With this, the new profit column will be created. Instead of this, without doing any calculations also, you can simply assign a list or a series to a new column name. This also will create a new column. Coming to updating a value, you can update values of an existing column by using assignment operator. By executing this code for the product name A, the sales will be updated to 120. Lastly, let's know how to save data. Saving data is essential as it allows you to preserve your changes for future use or sharing. The most common format for saving data is CSV. You can save data frame to a CSV file using the toCSV method. The index equals to false parameter ensures that the row index is not saved to the file. This will be the same for Excel JSON also. In place of to CSV, you need to mention to Excel or to JSON, and output file also you need to change to XLSX or JSON. With this, we end this episode. If you found this video helpful, don't forget to like, share and subscribe for more content on Python. See you in the next episode.